Hello and welcome back to From the Workshop. I am your host, as always, Brandon Hart. We are here once again in the fabulous NimbeLink Nerd Lair, and I am joined to my left, screen right, this fine gentleman whose name is...
Hi, I'm Kevin Holland, Principal Engineer here at NimbeLink.
All right, very good. We brought Kevin on today because we talk a lot about RF engineering and accommodating cellular connectivity into a device design and best practices and tips and tricks and all that kind of stuff. But here at NimbeLink, we've actually developed a whole device that utilizes a lot of those concepts and tips and tricks and things like that. So I wanted to bring the man on that was responsible for doing a lot of that stuff to have him tell you all about what we did, how we implemented those things. So that's what we're going to be doing. Right on. So as we mentioned, Kevin, want to talk to you about this little doodad here and kind of what it is. Maybe just before we jump into all of the nerding that you did to put something like this together, just a quick overview of what the thing itself actually is. What is this thing?
All right, that's our asset tracker solution. So basically, gives us a location. We put it on somebody's asset, and it talks to our cloud, sends the information securely over our cloud connection over cellular, and reports back location. Okay,
so this is a product that NimbeLink is selling now?
Yeah, you can go online and talk to our salespeople and order some.
Okay, very good. To be clear, it's a full end-to-end solution. This is not just the hardware.
Right, correct.
You specifically worked on the hardware. That's why we're bringing you on here. But the hardware is only one component of it. There's cellular service involved. There's a middleware platform called NLink that all of these actually report into. There's a dashboard if you want that kind of thing. So again, find more online. We'll put the URL down below. Okay, all of that nonsense aside, the actual device. Let's get into what makes this thing so special and the application of all of the years of expertise that you have in designing cellular IoT devices.
All right.
So first off, if we were to open one of these up and find the board inside, this is essentially it.
Yep, right? That's it right there.
That's where the magic happens. So one thing I'm a little confused about that maybe you can help me with, where does the Skywire modem go?
Right, yeah, so we designed the Skywire modem here at NimbeLink, and we didn't actually use it on our asset tracker product. So some of the reasons why we tell our customers not to use a Skywire, I guess, would be high volume situations, when you need a small form factor. And you know, those are kind of the two big reasons, and that's kind of why we didn't do on the asset tracker.
Yeah, so the whole device itself was designed to be as low cost and low power and everything as possible. And you know, because of the size constraints and because of the cost constraints, just like we've talked about here on the show multiple times, sometimes it makes more sense just to go straight module down. Yep. Right? So that's why that decision was made here. Cool. There's a lot more going on with this than just a module on a board, though. Can you tell me a little bit about why the device is the size it is and what this fancy piece of gold and black, was that fiberglass on the board here is?
Yeah, so the board is the size it is because mostly because of the 4 AA batteries that we put in there for user replaceability. All right, thank you.
Yes, I will be your banner.
All right, then a couple other things on the board are LTE antenna, which is your orange fiberglassy thing. We have a GPS patch antenna and Wi-Fi in there as well.
Wi-Fi?
Wi-Fi, which you might think would be weird, but we use it for location services. So similar to your cell phone, when you whip open your Google Maps and you get your location right away, it's using Wi-Fi SSIDs to give you your location.
Okay, so if I'm underground or if I'm in a in a building, or if I'm inside a large facility or something like that, and I can't see the satellites in the sky with the device itself, you're telling me I can still get some location information?
Yep.
Sweet. Does this device ever actually connect to and send data over that Wi-Fi connection?
No, it does not.
Oh, okay.
So we're only using it to collect data, and then we're using the cellular to transmit all our data to the cloud.
Right on, right on. Cool. So sometimes some of the Skywire modem, some of the devices that are out there, we talk about the combination of having the cellular connectivity and the, we'll call it generically GNSS, the GPS capability, the GLONASS, the Baidu, the QZSS, and all the other constellations and stuff that are out there. So how did you incorporate that into a device that's, quite frankly, pretty small?
Right, so we're using a standalone GPS module with a 25 millimeter patch here, which since the 25 millimeter patch is so low profile to fit into our case, we went with a bigger size antenna like that to give us the best possible signal that we could get. And one of the kind of key features of that is to get a lock as fast as possible, because we want to shut everything down in order to conserve battery life.
Yeah, battery life on something like this is pretty key. So with that antenna being kind of on the bottom of the board, is that right? It's on the bottom?
It's actually on the top.
Oh, everything flips
So
over
everything
like that.
flips. So you put the board in here and you flip it up, and the antenna's facing up.
And that's where the
This
side
guy's
skyward.
Yep.
Yeah, okay. So what happens if I flip it like this?
So depending on where you're mounting it, you're still going to probably get a signal, a GPS signal, because signals are bouncing off of everywhere.
Okay.
You might not get an optimal signal, but you would still probably get a signal.
And like this?
Like that. Yeah. If it's face down, it's probably not going to work the best.
Okay.
And the reason behind that is more so that you're getting something close to the antenna that's detuning the antenna, and it's not at the frequency of interest that you're wanting.
The Wi-Fi would still work for a situation like that.
Yep.
Okay. All right, cool. So you mentioned low power, and I think for anything that is battery powered like this, anything that is running an M1 radio or an LTE-M radio, whatever terminology you prefer, it's all about keeping that power draw down and extending the battery life as long as possible. For the record, what are we mathing the battery life on this to be?
So if you're doing one report a day, we're figuring out like 10 years of battery life.
10 years? Yeah. That's insane. How did you do that?
So
reveal your secrets.
Reveal my secrets. So on this particular thing, like I said before, you want to shut everything off when you're not using it. So the module for the cellular is shut off when we're not using it. The GPS is shut off when we're not using it. The Wi-Fi is shut off when we're not using it. And we're using a processor that has extremely low current during its sleep. So this product, when it is sleeping, is only 5 to 6 microamps, which is pretty ridiculous. And that all comes from shutting everything off.
Now you shut it off?
Yeah.
This is M1. Aren't we using power save mode?
Right. So the way some of the carriers have implemented power save mode, it is actually more advantageous right now to shut it off and deregister from the network than it is to be in PSM mode.
Crazy.
Now, that may change in the future if the carriers change some of their settings, but right now it's better to shut it off.
Huh. Okay. And how would somebody know that? How would they figure that out if they were developing something like this for the first time?
So kind of the way that we've been testing it out is, we do our regular transmit, power up, transmit, power down, and take power measurements during that. And we've done that with PSM as well as just shutting it off.
Huh. So experimentation.
Yep.
Testing.
Experimentation. Yep.
Trial and error. Like a great engineer. Perfect.
Yep.
Okay. All right. I got another question for you. Are you guys cooking pizzas in here?
Yes.
Why is this thing in the nerd lair?
We have the pizza, the paddle over here too.
Oh yeah, there we go. Nice.
This is actually, it's full of stuff right now. It's our RF chamber box here, so we can put things in there and block out the whole world of radio waves. And then also we can put things in there that radiate, and we don't get in trouble with the government for radiating things that we're not supposed to.
Okay. Is that one of the ways in which you were able to optimize the way that these things communicate?
Yeah, so one of the ways, you know, we want to go in there and see what the power level draw from the battery would be under different, you know, signal strengths. So one way to do that would be to put it in this box, put some attenuators on the antenna connectors, and, you know, kind of regulate what kind of signal is coming into there. And that's how we did some battery measurements.
Huh, very cool. All right. Well, awesome. Thank you for walking us through the asset tracker and the design and some of the design considerations that you had to go through, and therefore probably a lot of our customers and developers that watch will have to go through. For the record, man, this is a cool device. And so far, everything we're hearing is that it performs really, really well too. So kudos on the engineering. Not just you, I know. There was a whole team behind the thing, but yeah, nice work. Okay, so there you go. Hopefully that was helpful. It's fun a lot of times to talk about the concepts and you know, kind of what should and shouldn't be done in the development process, but sometimes it's a lot better just to see a device that was actually developed and see the application of those real things in a true device that has been launched and is a production version of a device. This is actually the second version of the asset tracker. So real quick, just as a parting thought, anything you learned from the first version that was incorporated into the second version, things that you were able to improve or optimize?
So we improved the sealing on the case. So like, so the environmental aspect of it.
Because this is a custom enclosure too, right?
We went with a custom enclosure on the second version, so we could get the dual sealing and some of the humidity sensing that went into the second version.
Did you have to worry with this enclosure about the antenna and how that might work with it? Yeah,
and that was another aspect. So since we went with this custom enclosure, the antenna itself has to be retuned to the custom enclosure.
That's interesting. Yeah. Huh. Okay. And is that something you did all yourself, or did you have to have the help of the manufacturer of the antenna?
So here at NB-IoT, we did it ourselves because we have, you know, some of the expertise and some of the equipment, but it's something that the antenna manufacturers could help others with.
Cool. All right. So you heard it here first. Seek out the assistance of your antenna manufacturers unless you've got a Kevin. Cool. Well, with that parting thought, please do send us any thoughts for future episodes or questions or concerns or anything like that that may have come up through the course of the episodes. Leave your comments down below. Like, subscribe, all the YouTube-y things. And we will see you on the next From the Workshop. Thank you very much and have fun building.